Hello students. Today we are going to see the 7th lab program, that is write a Java program to simulate working of shortest remaining time first scheduling algorithm, and we are assuming that all arrived at time 0. So before going through that program, I'll just explain what the SJF or shortest job first or shortest remaining time first algorithm. So the shortest job first algorithm, it it algorithm is mm, the scheduling takes place when a process length, depending on the process length, how the CPU will allocate for the process which has smallest CPU burst time. Okay, so whenever we give the processes, we give an input. So the process with shortest job first is given a chance. But there may be a chance like two processes with same burst time. In that case, the first come first serve scheduling takes place. Means the first process means the second process is given a chance. So to break a tie, FCFS is taken care of. So that's it. So that is how we will allocate a process. So we'll go through that program where we'll create some arrays for storing burst time, waiting time, turnaround time, and number of processes, because there might be n number of processes. Okay, so we'll ask the number of processes first. So we have just created an array, but we have not initialized with how many members. It depends on how many processes you want to give. Okay, so the moment the user enters, like 5 is the number of processes, so n becomes 5. So I will allocate a space for those many uh, processes burst time and its waiting time and its turnaround time and its process ID. So process is nothing but it is a process ID we are going to allocate. Okay, so after initializing all the arrays, I'll just take average waiting time and turnaround time, initialize with 0. Uh, for each process now I have to ask what is the burst time of each processes. So I will take care using the for loop. I will ask from 0th process. Okay, so for 0th process I will allocate the burst time. So think that I have entered process 1 with burst time 10 and process 2 as 1, process 3 as 2, 4 as 1 and 5 as burst time 5. So that is what we have entered for example. So for that burst time is entered into each array with index. So we are maintaining three arrays uh, for sorry, four arrays for entering your values. Okay, so after taking the burst time, so initially the waiting time and turnaround time of each process is 0. So we will assume it is 0 and we will initialize all the uh, array uh, array data with its process ID. So for example, we are starting with 0, but I'm just initializing it as process 1. So instead of process 0, I'm taking as process 0th location, process 1 is stored. That's why I is incremented here. Okay, so uh, for process all are initialized, then I'll just display what is the process ID and process you have entered. So you will get this. These are the values we have entered. Now this is what our algorithm. So algorithm is very simple. What we will do is we will use a sorting technique here. Why? Because the shortest job first is allocated. So I will just sort these all values. These value means the burst time of your process using a sorting technique. You can use any sorting technique. So based on that sorting technique, we have to sort the burst based on burst time values. So when I sort the burst time value, I am sorting the waiting time too. So waiting time of process has to be sorted because they are maintained in different arrays. So whenever the index of first array changes, the index of second and third array will also change. Means the burst time means BT is the array which maintains burst time. So WT is the array which maintains waiting time, and process is the array which maintains process ID. So whenever I change the burst time, in the same way the waiting time of that process and process process array will also change. Okay, so that's why we are maintaining three arrays here. So the moment you change the process ID, its burst time will also change, and burst time will also change, and the process ID will also change. So that is why we are changing this. So how to change? That's swapping. So I will swap all the values using that temp variable. So we know how to swap two members. So I will swap the burst time as well as waiting time as well as its process ID number with those three array. That's it. The moment you sort this, so the you will get this one. So this result, only these two, means process ID 2 is first because the burst time is 1. So that is the first one we have to allocate. Then process ID 4 because it's also having 1. Then 3, 5 and 1. So uh, after sorting my process ID and burst ID has been changed. So initially it was 1, 2, 3, 4, 5 when I entered, but it is been allocated in 2, 4, 3, 5, 1. So if you see the Gantt chart, first one is allocated at process 2, then 4, then 3, 5 and 1. So we have to calculate now this what is the waiting time of a process and what is the turnaround time of a process. If you observe the process ID means process 2 has waiting time 0, but its turnaround time is 1 because it has finished. Since it is a non-primitive SJF, means the process 2 whenever it is allocated it finishes its job. So that is the hint. So whenever process 2 finishes, the process finishes at 1 millisecond, then process 4 enters. So process 4 enters. The moment process 4 enters, what is its waiting time is 1. Then process 4 finishes at 2. Then what is the waiting time of process 3? What is the waiting time of process 3 is 2. So if you see that link, the logic process 2 finishes means turnaround time. That is the waiting time of your process 4. Okay, so process 4 finishes means turnaround time. So that is the waiting time of process 3. Then process 3 finishes at 4, then 4 is the waiting time of process 5. So that is how it goes here. So waiting time is 0 for process 2 because it is the first process, then turnaround time is 1. Now see, the waiting time of fourth process is 1. Then turnaround time is 2, then that becomes the waiting time. Then same goes here, 9 and 19. So till end of the loop, we are just copying that turnaround time as waiting time. So that is what we have written here. So turnaround time we can calculate using the formula. The turnaround time of first process is nothing but BT of 0th location plus waiting. So waiting time already I have initialized as 0 here. Then burst time of first process is 1. So that's why, sorry, process 2 is 1. So burst time 1 plus 0 is 1. So that is the turnaround time. So that is the turnaround time. Then waiting time of next process. That's why next process is waiting time of I plus 1. So I plus 1 is nothing but waiting time. So I plus 1 is nothing but 4 because we have changed our array as 2, 4, 3, 1, 5. So 0th position is second, first position is 4. Now the position is changed. So it is 0th position, first position, second, third and fourth position. So I plus 1 is nothing but 4. So that's why waiting time of I plus 1 means the next process is nothing but the turnaround time of previous process. So if you observe here, turnaround time of second process is nothing but that is the waiting time of fourth process. Then turnaround time of second process is nothing but waiting time of third process. So that is how it goes. So that's why we have written this for loop starting from 0th location. Why 0th location? Because already we have changed the process IDs according to our uh, the bubble sort. Now if you observe that code, uh, the last the last one is turnaround time of nth process. Why? Because the nth process, since we are starting with zeroth location, so the nth process, what happens is it breaks, means the loop becomes false, means there is only one process which we need to find out the turnaround time. Okay, so turnaround time we have to find out, but there is no waiting time. Waiting time is already found out in for loop. So turnaround time, we will, when we come out, the last process is remained, because the ith value here, the loop becomes false. So last process turnaround time is not found in the for loop, which we will find it in outside the for loop for nth process, means the last process. So turnaround time of nth process is equals to waiting time of nth process and waiting time of n. So n is nothing but here 5 what we have given. So that is the last process, first, second, third, fourth, and fifth. So this is the nth process. That's why we are just adding it. So this is the last uh, line we will add. So this is for last process. Okay. So now we will just print the process ID, burst time, waiting time, and turnaround time, which we have already found out. But what we need is average waiting time and average turnaround time. So how to find average waiting time and turnaround time? Just make the sum of all the waiting time. How will you make? The previous, this is like sum of array plus waiting time. So that's why we are taking average waiting time, then average turnaround time. So I'm just adding here. So this is the short term notification. So it is nothing but it is same as average waiting time is equals to average waiting time plus the waiting time of process. So this is how it is same as this. So it is also same. Okay. So when we find out the sum of average waiting time, now you divide it with the number of processes. So you will get average waiting time now. So this is the sum of waiting time. Now after dividing with n, you will get average waiting time, and same with respect to average turnaround time. So after calculating this, just print what is the average waiting time and turnaround time. So if you observe here, so this is how the average waiting time and turnaround time are printed. So we'll just run this code and we'll observe what is the output. Okay, so enter the number of processes 5. So I'll just give same 10, 1, 2, 1, and 5. So if you see here, initially the process IDs are given like this, but after that, after changing this for loop, the burst time with respect to that process ID and burst time, these has been changed. Now the order is changed here. Zeroth process is now 2. Okay, so for that waiting time we are calculating. So waiting time of that process is this, turnaround time is this. So average waiting time and turnaround time for those processes. So you can change the values of process and you can give the burst time. So this is the non-primitive uh, SJF algorithm, which we are assuming they arrived at time 0. Okay, thank you.